Right. Hello. So, yeah, this is moving better than I thought. Um, and what we're going to do now is so we have this get dependency types path, which we use to generate documentation for dependencies so that the LLM can use the actual dependency in the project as opposed to like this uh, over a long time different versions of the dependency and probably hallucinating a ton and not knowing about the latest changes in the dependency and so on and so on and so on. And currently we support checking the types field in package.json, and if it's not there, we go and check if we have a definitely typed, and if we don't have that, we go and throw an error. Now we're going to handle a much more complicated package, which is Firebase. So let's look at Firebase. Firebase, are you here? Wait, which node modules did I go into? Oh, I need to go into this one. So this one has OMG package JSON. So this has let's see, it uses the exports field. So there are a couple of things we need to do there. First of all, we need to queue based on, we're not gonna put all of this into like one request. We need to put each of these into their own queue. And to do that, we have to do a tiny refactor, I think. So let's take a look at that first. Let's see. Learn missing dependencies. Yeah. So I think, how are we going to do this? So the thing is, we can do this work. This is fine to do. Okay, let's do this, and then we're going to have another console here. Finding types for dependency. So we can do that just fine. Why are you complaining? Oh. And now we can have multiple types paths. By the way, let's just stop this process. So we should return multiple types paths, and we're gonna create a queue for each, or we're gonna add to the queue for each type's path. Yeah, so we have to even do more changes here. So this is tricky because we have to, yeah. It sucks. Like this doesn't return a promise. I think we need to fix that first so that when we add to the queue, we actually return the promise. Because we want to resolve this. No, how are we gonna do this? So this is gonna return a list of documents, but there might be, how the hell are we gonna do this? Are we gonna put everything into a single document? How are we gonna do this? Because the way it generates the documentation now is it creates markdown, which is great. Okay, so what I think we can do, we can shove it all into a single document. That's fine. So this promise of a document still needs to be a promise. But then we need to wait for all of these things to resolve. Okay, we definitely need our serial queue to actually return the promise of this item. And then what we're gonna do is we're gonna have the text for this. Oh my god. Okay, this is gonna be interesting. Oh my god. But I think we need to fix the serial queue first. So what I'm thinking in my head here now is that we're gonna have one piece of text, and then we're gonna append to that, and we're going to create like a main markdown header, which is gonna be what is that header? So that will be like analytics in this case. Wow. Wow, this is very interesting. Like I've seen exports that doesn't have any name in it. Like it's just dot slash. Oh, for fuck's sake. How are we gonna give it a name? Well, wow, oh my god, this is so annoying. Firebase documentation, like so authentication, for example, the way this is documented, manage users. So you're importing from Firebase /auth. Okay, I think I know what we can do. So we can join. So we can take the dependency and then we can join with analytics. Yeah, I think that makes sense because then it also works with if you don't have anything here, you just have the root, you would still have like the dependency name would be the header, which I think is fine. Okay, we're gonna do that. So for each of these, we're gonna add an item to the queue, which is gonna go and ask to create documentation for that, and we're gonna append that to like this general huge ass documentation for Firebase, where each main title is like Firebase / the export. That's what we're gonna do. And then, but the problem is we need to wait for all of these to finish, and we currently don't have any mechanism for that. So we need to fix that. So let's look at our serial queue. So this is so how are we gonna do this? Hello there. I'm just here building a dependency rag implementation for our coding agent so that it can learn the dependencies of the project, the actual dependencies, like the version and everything. And we've gotten pretty far. We're just managing some more complicated dependencies. And the complicated part is the documentation is based on typing. So it's a mix of the typing and the README in the dependency, because very often the README doesn't have any information. But oh yeah, I'm good, by the way. Thanks. How are you? Yeah, why LLamaIndex? So I watched a presentation, or a few presentations from LLamaIndex, and I really like their approach because they, unlike other solutions, and that might be because I've been biased as well. What the hell? Who is this? 9692367. Oh my god, fucking cookie. 6923678. Is that marketers? Yeah, so LLamaIndex, first of all, is an amazing company because they create all these tools for us, open source. But the reason I like them is that they started out building RAG abstractions and really figuring out how to do efficient RAG, how to get in touch with the real world, basically. And now they've started looking at, okay, how do we integrate these RAGs with actual LLMs? So it's primarily getting context, having great abstractions and primitives for getting context. And then it's now about like, okay, how do we give that context efficiently to the LLM? And how do we make that LLM more powerful, as they now have like an actual agent concept, which is basically giving LLMs function calls, but they also make their RAG solutions a first-class tool for an agent, which is really, really interesting. So I just like the way they think about how you make these LLMs actually able to do any valuable work. They need to get information from the real world. And the way they do that is through RAG, or like they could like search the web or something. But in the context of creating a coding agent, that coding agent really needs to understand the project it's operating in. I guess you can do updates and stuff. I haven't looked at it yet because I consider that like if this was actually going to be a production ready thing, then it would have to like be able to update. But looking at the index, where's the index? So you can choose many different ways to, you can store the embeddings in memory, you can store it in the file system, you can choose any vector database. So it feels almost like yeah, I'm not sure what to compare it to, but it's kind of like, just like you have these agent abstractions around any models, you kind of have LLamaIndex being a RAG abstraction over any vector database, as far as I understand it. But you have the doc store, and you can delete, and yeah, and when you add documents, you can, the false there means I don't want it to update. So you can just add documents with a true flag and it will update it. And then you have like delete document. It's very like, it feels like it's just a document store when you use the API, which is nice. Yeah, exactly. So this is incredibly complicated, right? How do you keep all these embeddings up to date with the source, the truth? And when you think about the source of truth in a project, it would be like the code and the dependencies. Like if you change the dependencies to like a new minor or major version, you want to relearn that dependency so that you, like the LLM actually understands how to use that new version of the dependency. And how do you keep that up to date? So, and a funny thing about that is, if you start this process, like you start up the development environment, and if your agent is integrated into that development environment, it basically just needs to either watch the file system, or you can use like Git. There's a like this very efficient way of just using Git, watching Git to see what changes. And then you keep it up to date that way. But what if it's not integrated into the environment itself? Like you're using it locally. So you might choose to start the agent. And then how do you know? You don't want to go and like flush out the old stuff and then relearn all the dependencies and all the code and everything. So one way to do that is using metadata. So you have like the modified time of a file to figure out if you actually need to do anything. So when you start the agent locally, you have no idea what's changed in the meantime. But so you would indeed go through everything, and then you would verify if any files has been removed, if anything's changed, and all that stuff. But it's interesting because that's what I think why agents should run in the cloud, is that you can integrate the agent with the environment. So the environment won't run without the agent. So it will always be in a state where it's in sync with the file system by just watching it. Because you can't only start the environment and not the agent, where it can get out of sync. Yeah. Relevant chunks. Yeah, no, I have no idea. I haven't actually reflected on how to keep rags up to date efficiently. Like it is fundamentally like a tricky thing. That's for sure. I had this other thought as well. What was that? What was that? Now I can't remember. Yeah. Yeah, I can't remember. But maybe the most tricky thing is, what if it isn't synced? Like there's something went wrong. What if something went wrong and suddenly you have some stale information related to some dependency documentation that was generated, or some information related to a file? There's no way to know that by using the agent. Like maybe, okay, I guess one example would be, hey, why did you use this this function from this API? It doesn't exist anymore. Like that will give an indication that it's out of sync with the documentation of the library or the dependency. But it's so vague, right? It's so ambiguous. So it's very, very tricky. It would have to be very reliable, the actual syncing. But even then, it like I just had on the previous stream, I had published a new version of a library I built, but I forgot to update the README. So the README had the wrong reference to a function. It was renamed, and the README had the wrong version. It actually, the dependency rag built the correct documentation because it was using the typings. But as you can see, like it's even the source isn't 100%. So it's very, very interesting and tricky. But yeah, my goal now is really to build up dependency documentation reliably. And there's so many variants of this in JavaScript, where the typings are and how they're referenced. So I want to kind of get to a place where we can consume most dependencies. And then this whole story of keeping things synced is is a huge ass problem in and of itself, but I don't think that's a problem that needs to be solved unless you actually intend to put something like this into production. So it would be like a later problem to solve. And especially web guides. Yeah, it's interesting, like using websites. That could definitely be like, we're talking about where is it? Like learn missing dependencies. That could be partly going through the types, but also the latest documentation on the web. I have like two worries. I worry it's gonna take a long time. Like there's high latency on that. So when you start, like when you like fire this up the first time it goes through the dependencies, it's gonna add a lot of overhead to the latency of learning those dependencies, I think. Maybe not. I don't know. But I imagine like going there and scraping everything. And there's so many, like, and here we're just talking about like the pitfalls of analyzing a package JSON to find the typings. Even there's a lot of pitfalls and many variations. And then going and scraping a website, it's like there's a shit ton of more pitfalls to get like a good structure on that. Just look at Firebase. Like their documentation is all over the place. There's some iOS, Android, Flutter, and then you have web. And within web, you have modular and namespaced. And it's like, how do you reliably scrape this stuff? Yeah, you could do it. Yeah, that's a good idea. Like you can do it. You get the most immediate, efficient thing, and then which is local, and then you can go and lazily go and enhance those dependencies. GPT researcher. Oh. Design for comprehensive online research on a variety of data and can produce detailed, factually analyzed research reports with customized options for focusing on relevant resources, outlines, and lessons inspired by the recent planner, Sol, and RAG papers. Increase speed through parallelization work as opposed to synchronous operators, empower individuals and with accurate, unbiased, and factual information. Oh, there's a demo. That's always good. Thinking. Have you tried it on a dependency? That would be interesting. Is there like a demo? Oh, that would be fun. Just try it on... But this is really cool. It would be fun to try it on a dependency, see how well it works. There's also this other thing called, maybe we can try that, browser AI or something. Browse AI. Get started. Let me... Yeah, I have to be, sometimes when I like make a decision on going one path, I get very, what is your name? I'm in Norway. I get very defensive because I want to protect like diving down a certain path. So when people say, yeah, but you should also look into this thing. No, I'm on this path now. Don't, which is not healthy. I don't know. Where did I hear about there? No. Okay. Yeah, I want product updates. Robots extract. Oh, monitor site changes. That's interesting. Uh, yeah, I wonder how would it actually be able to figure out by version, because most websites doesn't have um, versions. Like they just have major. You might like some websites they have, like even Firebase doesn't have this. Like there's no version here. You have modular and namespaced. It's not like version. And some websites they have like okay, version 2 and version 3, but they don't have minor version changes to their documentation. So it's like it just feels so unreliable. It's super reliable if you happen to install a dependency with the latest version and then go and scrape. But as soon as that dependency gets like 6 months old, and you happen to generate the latest documentation again, you might be pretty fucked. Because then the website does not reflect the current dependency running. Uh, um, yeah. Hmm. 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 Yeah. Oh, for guides. Yeah. Yeah, exactly. No, but it is really interesting because they're like, and one thing is documentation. Like, if you go and do this research, like you just go on the web and figure out how to do something, it doesn't only rely on documentation. You have a lot of articles that's also writing about. Oh my God, sorry, there's noise outside. There we go. There's other sources of information that's very valuable to understand how to use a dependency. Uh, oh, and then start training robot. Yeah, I guess this was. Well, I could go and try the Firebase. Let's see. Firebase docs. I wonder. Start training robot. Improved UI, no need to install anything. Okay. It's really cool. They did a great job with the user experience here. Look at that. uh, oh, okay. So it's quite manual. Okay. Whatever. But yeah, this is really cool. Huh. Oh no, I was just like there wasn't any demo of researcher. I wanted to just try and actually ask for documentation for a dependency. Oh, live demo. Oh no, that's also a video. Yeah, I just wanted to test it, but there wasn't any easy way to do that. It seemed like I guess I could like try to run it. Yeah. One-click deployment. Generate research outlines. Hmm. Yeah, I was hoping that Browse AI had something similar that you could just give it a URL and it would kind of scrape it. I was curious what it would do with a Firebase website, but yeah, it was very manual. Where were we? Yeah, I wanted this serial, but yeah, it's such an interesting thing, and like I mentioned in the previous stream, like this is the non-sexy part of making agents work. It's like, how do you provide it information? Like, it's so magical to see when it has the right context what it's able to do, right? And then it's fun to do like some prompt engineering to make it like deal with that context in certain ways. It's a lot of fun. It's like a new way to do programming and building products and value. But then when you get into like how to provide the correct context, it gets into very traditional programming, which isn't as sexy. Let's see. I think what we just need to do here is we need to create, we need to do this little promise trick. So I just need to return a promise from add that resolves when the item has actually been evaluated. And then let reject. And then what we're going to do is create the promise, new promise. So let's call this resolve reject, and then resolve equals resolve. Nice. And that's basically it. And then we need to get the actual, let's say, queue item. Let's do a T here. We actually care about the return result now. So this will be any. And now we can do queue item T. And we can say this should result T. And then we can return the promise, and that should give us the correct typing. And then what we need to do when we push to the queue, we should not only push the item, we also need to push the resolve. Oh, we need to push the, so this will be an array of item resolve and reject. Yeah, something like that. And then we're gonna push the item and the resolve and the reject. Yeah, this is so annoying. Can I do this? No, that doesn't work. Can I do just this? Oh. It's just because it doesn't like callbacks. It's really interesting. Like, I know that this callback is synchronously run. So I know that resolve and reject is actually assigned. But TypeScript doesn't know that this callback is synchronous. So it throws an error on the thing. Okay, so now we have that queue. So when we have the next item now, we're gonna call item. Let's see. So I guess what we want to do is try catch error. So we're calling this item. Oh, you know what we can do? We can just do this. Then next item resolve or next item reject. I think that should be enough. And then we'll shift yeah, which removes the item, and then I think we're good. I think this will work. Let's try it. So now we can wait for this. So add now returns promise void, which is fine. But what we're gonna do here is we are going through all the missing dependencies. We create a promise for a document. And this document is gonna be, let me think. So if we have the types path, oh, sorry, yeah. So this is gonna return an array of type paths. That's what we're gonna do. And then we're gonna return, or we're gonna await all the types to resolve. And then we're gonna build that up into a singular text thing. And then we're gonna resolve that as a document. That's what we're gonna do. So where should we go next from here? I guess we want to go and figure out the exports thing. So did we have that? Let's use Firebase here as a... So we have exports. So what we want to do is... Okay, so if we have a typed field, we're going to use that. Or if we have package.json.exports, we're going to take a look at them. And what we want to do here is basically go through the keys. Yeah, and actually we're going to make, get dependencies paths instead. And this is going to be return an array of like this. Do we also want it to return we also want to know, yeah, it's not gonna be, it's gonna be an array of types, string, and it's gonna be a name. Because the thing is, like, normally the types is there's like one type file for the dependency, but in terms of Firebase, you have multiple exports, named exports. So you have like Firebase Analytics, Firebase App, and so on and so on. So we kind of want to keep the name in there. Let's just call it name. And what we'll return here is, oh, sorry, it should be path. So this is the path, and the name in this case, since it's just one, it's the dependency name. And then if we have exports, we're going to go and grab the keys. Object.keys, package.json, or names. Let's call it names. So we're going to grab the keys, and then we're going to map those keys. And we're going to join it with the dependency name. Dependency key. So what happens now is that we actually get a names of Firebase/analytics, Firebase/app, Firebase/app-check. Those are going to be the names. And then we're going to run through these names. And we're going to, what are we going to do with these? So we could filter them and make sure that they have a types field. Yeah, let's do that. So yeah, let's do that. Filter. You know what? Let's do a filter on the key. Key boolean of package JSON exports key types. So if it has a types field, and then if no names dot length, we're gonna throw an error that we can't find any dependency types. But if we do have names, now we can go in and we can actually go and grab the types. But now we have a different problem. You know what? I think this shouldn't just be the types path. I think it needs to be the types, because yeah, it has to be the actual types, because now we're also going to go into it's so complicated. Like the types path here is to a file that just exports a different typing file. So we actually need to be able to go in and grab the, so we're gonna actually return the types here, and we're gonna call this get dependency types. So we're actually gonna read, yeah, and what we're also gonna do is we're gonna create a helper function here for read file path string return fs read file, because I'm doing a lot of that stuff. Let's just call it so we're gonna read file. We don't have to do this. I'm gonna do package JSON, so we're just gonna parse that. Yeah, I think this is fine. So what we want to do here, we actually want to read this. So read file await. So this would be the file to the type. So we get the actual types here. Whew. And now what we want to do is promise all names. We want to map those names to well, no, wait, this should be types. Types. Ah, annoying. Yeah, so this should be types. And then we're gonna map. Yeah, sorry. So this is gonna be. Ah, for fuck's sake. Keys with types. So first of all, we're just gonna get the keys with types. And when we have those keys with types, we're gonna have key. And then we're gonna have types path, which would be package JSON exports key.types. That's the types path. And then the name would be dependency path.join dependency key. So that's the name of it. And now the interesting thing happens. Now we need to evaluate the contents of that file if it's just an export to a different file. And then the question is, that's probably something that should happen here. No, that's not something that should happen here. That should happen. Yeah, it's interesting. Like, what do I expect? I guess there are libraries that has a package.json file with a types field that points to a TypeScript file that just points to, that has a single export to a different package. That could probably also happen. So where do we actually go and check this? Yeah, I think it's not enough to just read the file. We also have to create a function that takes the path to a type and then returns yeah, okay. Oh my god, this is complicated. Function evaluate so either it actually holds the types or it just holds an export to a different file for types. And if that's the case, it's like a different but this is also, I don't like this. I don't like this at all, because okay, so the problem is this. So we want to go and learn about auth, and it has its own package, JSON, fine. Let's see, and then we have app, and this just has this. But this could be a relative thing as well. And the problem is that since this is like an path to a dependency, we have to go and read the package JSON to figure out where these types actually where they are. I wonder if tsmorph is able to figure this out. That would actually be quite interesting. Yeah, so the problem is just, I don't know how common this is, but Firebase, they proxy their types through to a different package. So you have a Firebase package, which has type references, but those type references are to these kinds of typing files. It's just a proxy to a different package called @Firebase, and then the namespace of the API. And I need to resolve that. And the question is, how do you resolve that? Like, what assumptions do you need to make? Because should us or what are we looking for? Are we looking for, okay, if the type definition file for a dependency only has a single export, that means it should go and follow that export? Or should we just say, if the type definition file basically has export star from something, we should also go and include that? I guess that makes sense. So it's not a matter of like handling Firebase per se. It's just that, okay, if the type definition file, so the point is some of these files has imports. We don't care about the imports, but we do care about the exports. So maybe that's the thing we want to build is if the type definition file we're referencing for learning has an export from a different file or package, we want to go and include that. Challenge though is this can be a relative path, which means we just have to follow that path and find the file, which is it's in the same package. Or if it's like an pointer to a different package, we have to go and look at the package JSON to figure out where the actual typings are. Yeah, but I think we can just check that. So we can use tsmorph to find. Maybe we could even just use a regex for this. To find export star from. Yeah, let's just simplify this. Let's just use a regex. We could use tsmorph and look at the syntax tree and kind of find these actual nodes in the code. But I think we'll do fine with the regex for now. So basically the regex is identify this pattern. Problem is sometimes this is like double quotes, sometimes it's single quotes, but we can take that into account. Yeah, it should be straightforward though. Like if it starts with /, it has to do that. Or we're gonna make two quick decisions. It's like we're gonna use a regex for this, and if the regex starts with this, it's like a relative file path. If it doesn't, it means it's the package. Yeah. So what we're gonna do is we're gonna create this function called resolve types. I think. So we're gonna make an assumption that any, yeah, okay, resolve nested types. So get dependency types is based on a package and it's package JSON. And then whenever we go and read types, we're gonna resolve any nested types. Not nested in terms of imports, but nested in terms of exports. Because there's some stuff in that type definition file that is not present because it's been exported from a different file. So we're going to do that. And then if there's a match on an export that's a package, we can just call get dependency types again. Because then we pass in the package JSON for that package. And then it will just do the nested resolvement. So it should be aggregated in that sense. Yes. So we're just going to get types path here. And this is going to be async. And then we're going to move resolve nested types. And this would be package JSON types. So these would be the types. And then we can do our regex to find the exports. Exports would be types match Oh, this is interesting. Is this the actual? I wonder. Let's look at that one. That's interesting. JS regexp. Online. Yeah, sorry. I have a tendency to make notes in my head. Sometimes I find it better to write notes. But when I'm in, like, when you're kind of thinking about something and you're kind of, okay, I'm almost there. And then it becomes disruptive to kind of change the approach to kind of resolve your thoughts. But I think by default, it's much better to have a tool to keep track of your thoughts. But I have a tendency to just operate within my brain. Yeah, exactly. Let's see. Well, it's not export. It needs to be export at least. Export. What was it? Star from at Firebase app. Yeah, that didn't seem to match it. Let's try to write our own here. Export star. So it will always be. Well, this is interesting. Because this can also be destructured, right? You can have this kind of thing. So let's do, how is this? From, and then there has to be a space there. Is that S? No, that's space, right? And then we want to get access to you know what we could do? No, let's see. And now it needs to be let's see. Isn't this how you do it? So it's either a single quote or double quote. It can't be anything else. And then we capture that, and then we say it needs to be this or this. And we don't care. Like sometimes you have the last thing there, but sometimes you don't. So if it's like this, it doesn't matter. It's like foo. I think this would work. Like we have to start somewhere. So this should give us, yeah, group 1 has Firebase app there. Okay. Oh. Oh, but is it match? Is it like match all? Yeah, match all. Oh, does this become? Oh, what the hell happened? I have some epic latency here. What did I do? What? Oh, something bad happened. Whoa, I got disconnected. What the hell happened now? Okay, let's just reload and see what happens. I did copy the code in case we... Well, that's interesting. My VM broke. I'm gonna report this. I'm gonna report it. Oh wait, did everything? Are we still online? Oh, my Slack broke on my other computer. Wait, what's happening here? Do we have internet? Yeah, I'm still on the stream, right? Oh, look at this. Okay, what the hell happened to my VM? I'm gonna. My VM just broke. Cannot open it. Cry. Oh my god, this sucks. This really sucks. Let's see, I'm just gonna shove. Yeah, I should really improve my tooling game. I'm sorry, like if you look at me like if you would only look at me coding, not talking or anything like that, you would definitely think I just started coding. I don't learn any like fingertip efficiencies. Is like I don't know any shortcuts for like commenting out code or anything like that. The furthest I've gone is like rename symbol. That's the one I use, but I don't use a shortcut for that. uh yeah, I'm incredibly inefficient when it comes to the actual my fingertips. Yeah, I don't think we're actually able to continue here. We kind of need a VM to, be able to work on this. The server responded with a... Oh, here we have the ID at least. The ID is XV84D. Unable to start. I think we are having some infra issues. Why do you want that? Huh. Okay, this is sad. So I'm gonna stop the stream because I think I have a colleague who's trying to fix this, and I'm gonna give him some moral support, and then I'm gonna kind of just prepare this. Yeah, it's a code sandbox issue. We have an infra issue. Yeah, please give me suggestions, and I can reflect on those until the next stream. Yeah, should work on it. So there's a big challenge is I'm trying to keep the scope. The reason I'm keeping it like incredibly an incredibly like pointed scope is there's so many things. My intuition tells me there's so many things that's going to pop up if I extend the scope. So one thing is like moving from TypeScript to like a different language like Python. But just solving mono repos, like people have mono repos, and now the package JSON in the root doesn't necessarily reflect the project you're working on. Or maybe you would point the, oh yeah, but you would point the agent to the package that represents. Yeah, you could argue that. Like this agent, you need to point it to an actual workspace that is the app. Like the package JSON in the workspace represents the actual app. So it doesn't like support mono repos. Or if it were to support mono repos, you will have like one agent per like workspace in the mono repo, whatever. Yeah, but those are the things that's swirling around my head. So that's why I just went straight into like, okay, let's just make a package JSON work first. I'm not sure, like, how does Python handle its dependencies? It's just some dependency file, like package JSON, I guess. Aider? What's Aider? Wow, you have a lot of. What's your background on this? Yeah, what's your background on like AI and where are you at? Is it like an interest and exploration thing, or are you actively using it, or Aider AI? Oh, the Norwegian accounting. uh, what's Aider? Is it this one? What's this one? The future of AI code generation. It's like when you say this, the future of it's like it doesn't matter if it's AI or anything. It's just generally if you're part of the hype train, you have a tendency to use this. Even I've used this, the future of. But this is what I don't. Uh, this is what I don't like. See it in action, writing code for a full game in one click. Like there's so many examples of writing a game. Like you don't need anything but an LLM to do this. It might do a poor job, which might be the case even here. But this isn't impressive to write code for a full game in one click. What's impressive is making updates to a project. That's impressive. Anyways, sorry, I don't mean to like I'm bashing on this project. I don't mean to do that. For coding and offering tailored suggestions and improvement. Yeah. Yeah. Sorry. Yeah. Aider. I'm trying to find Aider. Oh, this one. AI business strategy and integrating AI solution. What kind of? That's really cool. What kind of end products are you kind of building with atomic agents? Like what kind of experiences? Or is it like internal tools for businesses, or does the businesses have like customer facing products using AI? This is interesting. Oh, kind words from users. Ah, that makes me warm and fuzzy. That's really interesting and so cool. Like making this kind of UI in the terminal, even that's impressive. Uh, yeah, and using diffs to change the gross files. Yeah, I talked to a colleague about this. Like, what? Oh, actually, we should be back now. About like, how do you want to apply changes to your code? Do you actually like we're doing with the agent I'm building now, it basically has the capability to read a file, and then it can update the file and write the file. But what if you created like Git patches instead? That's really interesting. Because at the end of the day, if you like, it's so interesting to think about the abstractions. So if you think about what's the abstraction over manually changing a file, a single file, like a line in a file, it's really, you can apply a Git patch to number of files with number of changes. Like it's just a higher abstraction of making a change to code. So what if that is what you use to make changes instead of like this horse and carriage approach of opening a file and editing it? Oh, look at that. We're actually back. Okay, we can continue the stream. That's nice. Okay, does it actually have the stuff we were working on? Oh, that's... Yeah, nice. Many smart without getting you locked to the framework. Instant function calling, web fact checking, etc. Yeah. How do you... I just watched this interview with, I can't remember his name, I can't remember his name. But he's a consultant who's been implementing like RAG applications. And they were talking a lot about like, how do you validate the performance of doing RAG? And one thing is validating the actual RAG extraction or the RAG. Another thing is validating putting that retrieved context, putting it into an LLM, and then validating the output of the actual LLM. Oh, three-way conversation. That's really interesting. But yeah, I'm super curious, like how do you validate the performance? And is it like simple in the chat? You have like thumbs up, thumbs down kind of thing, or let's see. Let's try to get this thing running. Yeah, so this would be export, and I guess each of them would have. We can map that match to like so. Oh, can this be null? No. Can this be null? Match all, should that always be? Ha! It's an iterable? Ugh. Why is that an iterable? Okay, so we have some potential exports, and what we're gonna do here is we are an auto, yeah. From user response, yeah. How does that, I was curious, how does that actually work when you get, how does that go back into the agent? Like you're having these, it's having these conversations with users and they're saying, hey, I didn't like your response here. How does that, what actually happens when you click thumbs down? Yeah. What happens when it when a user clicks thumbs down, like conceptually? Like even in ChatGPT, you can do that. I wonder what actually happens. Like, is it automated? let's see, we have these exports. If it's so I think what do we want to do here? So we need to resolve these exports. Nested types. Oh, look at this. Look at what you did. This is pretty awesome. So what we want to do here is we want to grab the nested types by going through our exports, but we want to check this thing. So if export path starts with, let's just do dot, then we're going to do this. And if not, oh my God. We have to go and find the package JSON and run get dependency types again. Okay, I think this needs to be. So if export path starts with dot slash, then we're just gonna resolve that thing. Oh, what did I do? There we go. So if it starts with dot slash, we're just gonna resolve that by reading the file. The question now is, it should be relative to the types path. So is this the full types path? Yeah. So this would be types path export path, I think. Oh, is it running? It doesn't need to run. Oh, it's saved for future learning. Okay. Yeah, you just generate again. Yeah, exactly. Yeah. So yeah, so it's kind of like you just keep track of all the thumbs down question responses, and then you will kind of integrate that into some later like fine tuning kind of thing. Okay, so when that export path is relative, we're gonna just resolve the nested types. I should have isolated this so we could test it more efficiently. But we're gonna pretend that we're amazing developers and things just work. So the thing is, if it's an actual package, we need to go in and read that package JSON file. So we should be able to do this. We can actually just do this. So what we would do is call get dependency types, and we can say workspace path, and the dependency would be the actual export path. And then we're gonna await getting the dependency JSON workspace path export path. Yeah, this can be async. That's fine. Okay, this is crazy stuff. So basically, we are grabbing all the exports. We're iterating those exports, and we'll get the actual path, export path or dependency. Let's call it export path or dependency, just to be clear. So if the export path or dependency starts with dot slash, it means it's an export path. So we'll just go and resolve the nested types of that thing. And then if it's a dependency, we'll go and get the dependency types again by grabbing the package JSON from that dependency. So now we have our nested types. And what do we have here? So we have the actual types. So we basically need to return. Now the problem here is no, I think this is fine. We just need to return types and nested types. Oh yeah, nested types is like, oh, is it an array of, oh yeah, fudge. Wait, we have one problem. Well, not problem, but one thing we need to resolve. Okay, so get dependency types takes this using the name. I have to think, because here we are within the same name. So the question is, when we go and ask for get dependency type, so that means, okay, so we hit export from a different package. But we should, in this case, we don't really care about the name anymore. Okay, so I'm gonna do one thing here. We're gonna and that's nested nested types from dependency. So we're gonna use those, but we're just gonna return that. We're gonna map over those because we only care about the dependency. We only care about the actual. Wait, shouldn't this be? Oh, yeah, we only care about the actual types here because we've already resolved the name of this type at the top. So as we dive down into like nested packages, we've already resolved the name, so we don't care about that. So this will be join. Why are we splitting? I think this should just, oh, because this one resolved. Oh, that's an any. Oh, we haven't actually returned anything yet. Why is this wrong? Yeah, this should be a string. Oh, what the? I hit the wrong button. Ah, oh, come on. So this should be a array of promise string array. What the hell? String or this is a promise of a string. Oh, sorry. So this is an array. Oh yeah, sorry. We have to flatten this. Flat. Wait a minute. Why is this? Why does this need to be flat? Yeah, no, it doesn't need to be flat. We just need to join them. Yeah, sorry. So we don't We can do 2 lines. I don't know. Yeah, sorry. So this is, of course, isn't promise. Now it's correct. Sorry. My brain is... yeah, let's do double. Okay, anyways. So this is... wait. Oh my god. Okay, let's just review this. Yeah, we're gonna fix that. So the point is... Thank you. So the point is, if we just have a types reference, it still goes in and it resolves nested types. Like that type file, type definition might have exports of other types that's relevant for the public consumption of that library. So it does that, and the way it does that is it takes the path, it reads the file which holds the types, and then we look for any export statements with a regex to simplify it. We go through all the exports. If that export is a relative export, we go and we just resolve the nested types again from that recursively, and then that finally returns just a string of the actual types. And then if it's a dependency, we go and actually get dependency types again. We reuse this function, which goes and it does that by reading the... Do we need workspace path there? Wait, get dependency package JSON. Oh, sorry. Yeah, sorry. So here we have the actual, like in the string, in the quotes, we have the actual dependency name. And workspace, we read the package JSON of that. And then it will go and like figure out as if it was a new package JSON or like a root package JSON, but it's just nested now. And then since in this case, we don't care about the actual name that's being resolved because it's part of the top level name, we just map over it and grab the types. And then we return the actual types and then the nested types. Oh, yeah. So this is not... you're perfectly right about that. So this is not for diving into dependencies of the dependencies. It's just that some packages exports their types from other packages. So that's what we see with Firebase, for example. So Firebase has like Firebase as its npm dependency, but it exports types from a different package called @Firebase that you can see here. So that's the only thing we're doing. We're not like looking at the dependencies of dependencies. We're just basically, we have a type definition file. We'll dive into that type definition file until it's like exhausted. Cool. So that should work. So now we have exports. And what we need to do here now... Oh, yeah. So now we have the types path. We have the name. So we should be able to return this. And for some reason it doesn't like that, and that's because... Oh, we need to await it. Async. Okay, so now when we're in package.json with exports, we go and we find all the keys with types. And then we do exactly the same thing, only we do it for each. We do it for each export. And here it gets its name, which is based on the dependency name and the export key. So that means it would be Firebase/analytics. That would be the name. So that's all well and awesome. And then we kind of do the same thing for definitely type dependencies. Get dependency types. Yeah, so here we also just go in and we basically reuse the function where we just changed out the package and the package JSON with the definitely typed one. So this should work in theory. So the only thing, yeah, oh yeah, it's a promise of this. Nice. And now we just have to await types, and this is more like types now. It's not type paths. So we can call it types. And then for each type, we're gonna go in and add to the queue. So this would be, it's gonna be interesting. So we're gonna iterate all the types here and create usage examples on them. And the way we're gonna do this is, I'm just thinking if we should, I think it's fine that we, so usage examples would be basically queue add. Yeah, sorry. So usage examples would be types, and then we map those types to yeah, because here we're actually reading. Yeah, this is also interesting because well, first of all, we need to do promise.all. So we're gonna do two things here. We're gonna oh my god. We're gonna, let's see, we're gonna take the readme content here. Oh shit. Ooh. Oh yeah, sorry. So we're gonna do types and readme. So we're gonna promise.all this and reading the readme. So we have the readme over here. So that would be, we can just use read file for that. Oh, what did I do? So we can remove this and we can do read file. Okay, so we have our package, our dependency. We go in and we find the package JSON for that dependency. And the reason we do that is that we can pass that package JSON into get dependency types. And then that will recursively resolve any types. And then we also read like the initial readme. I don't think it makes sense to do any nested readmes. It seems to be, yeah, let's just not do that. So we get the actual types here, and then we also get the readme. And now we can create usage examples by iterating. Yeah, that's a little bit tricky here is we have multiple types now, but we still only have one readme. So yeah, we kind of need to move this into its own. How are we going to do that? Oh, sorry. I forgot. So one thing we wanted to do here, we want to go through all the types and generate like one type definition of that. Oh, yeah. The challenge is I think we can try to just use a comment for this. Like what I'm having in my head now is that these types is an array of the actual types and the name of them. And we want to compress this into a single string so that we can include all the types and the README as like one request to OpenAI, in this case, to generate the documentation for it. The thing is that this name needs to be included in that typing. And what we could do is, you know what? Yeah. Okay, we're actually going to iterate over the types here, and then we're going to give each of these code blocks a name, which is the name of the dependency, just to shove it in there and see what happens. So what we can do here is, oh, this is interesting. We actually didn't need all this return stuff, because we can still now just do qadd. Oh my god, did we do all that for nothing? Well, it wasn't that much. So what we can do now is say learning dependency, asking to create usage examples. Yeah, let's just do learning dependency. And now we have README. And what we're going to do now, we're rather going to do types, and we're going to map those types. Exactly. But we're going to do it a little bit differently. I think it's enough to like do something like this. Let's see. And then we have the types there. I think maybe we should just, since we're in a template literal, let's just do this. There we go. Okay, from this README and TypeScript definitions of a library called dependency. Okay, this is great. I think we're there now. So let's just comment finding types, finding package JSON. Finding types for, and then this is the rate limiting queue thingy. You know what? This should be really fast. I just want to have good logging, so we can actually put this inside the queue so that it like sequentially resolves. I love your enthusiasm. I usually find myself on that side of the table like, let's go. And I have a colleague who's kind of more what's it called? Conservative, I guess. But I just want to log how we're doing this stuff. Get dependency types. I just want to say resolving types from types field, and then resolving types from exports field, resolving types from, yeah, let's just do this from exports. JSON stringify keys with types plus something like that. And I want to know when it finds console.log resolving nested types from export path or dependency. Okay, let's put that up here so we know. Okay. Now the thing is, Firebase is freaking huge. But I think we can just run it regardless and see what happens, because now it should identify that, yes, indeed, we have a new package, which is Firebase. Did we actually add it? No, we didn't. So we should do that first. I removed it because I... so we have Firebase there. And now it should identify that it's missing Firebase, so you should try to only resolve Firebase. And the way we can manipulate this to kind of, well, first of all, if it fails, it fails. So it doesn't actually write it to the thingy, to the dependencies, but we can also manipulate it here, right? We can just remove it to run it again. So that's nice that we have that now. Okay. Let's go. I wonder how much. I really wanted to just do one. You know what we're gonna do? Sorry. I just want to have a controlled example. So we're gonna manipulate the package JSON file so that, or the exports, so that we only generate for analytics first. Let's see, because there's a lot of them. Messaging, remote config. Oh my god. You know what? We're gonna rename this to old. And then we're gonna new file package JSON. Let's see. So we're just gonna do it for analytics first. Let's see. There we go. Okay. Let's go. And the find. Okay, let's check it. Not quite sure why it says .types. So package JSON exports. Oh, sorry. My bad. Oh, not exports. My bad. The path argument must be a string. So this was in resolve nested types. Oh, yeah, and here it just goes and didn't we keys with types? I'm just gonna check exactly where it goes wrong. So this is path join. Oh, interesting. Oh, package JSON. Oh, sorry. This should be types path. Oh, this should be, oh, it shouldn't even be this. Like, this is the full types path, I think, isn't it? Resolve nested types. No, it's not. Okay. It should be the full path. So we're going to do types path like this. Yeah. And then we need to okay, let's see. Oh, sorry. So this should be so here we are actually in the exports of the package JSON. So we have the dependency, we have the types path, and then we need to do something similar with this thing. Package JSON types. Because now this resolve nested types handles also like relative paths and everything. So it should just get the full path where it needs to resolve things. And then we have, I think, yeah, I think that's it. I might have forgotten something. But that should help. Let's see. With non-global. Do I need the G thing here? Oh. Yeah, look at this. Resolving types from analytics, nested types from Firebase analytics, resolving types from exports. Oh, look at this. Initialize Firebase. Using analytics in Node.js environment. I think it's working. Basic Firebase initialization and analytics setup. Yeah, and here you have log event, page view. Yeah. Setting consent, set consent. Look at that. It's working. Nice. Amazing. We did it. So now we just need to replace that package JSON file and try to run the whole Firebase project and see what happens. And did we get some pricing here? Didn't I add price? Oh, where did I add that? Oh, I think we should put that at the end. Let's just put it there. It should be up here somewhere. What was the cost of generating this? There we go. It was like 0.05. Yeah. This is cached. Yep. And what I really hoped is dependency rag, like the dream scenario for this dependency rag, is that we find it to be so good and reliable that we could create a service out of it. So that people wouldn't need to run this dependency rag locally, but they could just call a service to get usage examples. and then of course cache that locally, but it wouldn't have to be generated again. So that's the nice thing about version, right? If there's a version, we can generate for that specific version, and then nobody else has to generate that again. But that's given that we found a good prompt for creating those usage examples and so on and so on. And that it actually resolves types and we find it valuable and all of that. But that would be really, really nice. So you can imagine installing like an npm package called dependency rag, and it would just call a service. And if for some reason, well, not for some reason, but you give it your package JSON, and it goes and it finds all the usage examples, and then it generates usage examples from the missing dependencies and caches that in the cloud, and then other people will get those examples or usage examples much faster. But again, that's also then stored locally, cached locally, so that you don't even have to call the service to go and grab the usage examples again. That would be amazing. And I think that would be a valuable contribution to, especially to JavaScript that has this, like, yeah, just looking at how typing, like you have definitely typed, you have all these different ways of referencing typing and so on and so on. So, but yeah, that would be the dream, to actually have a service for this concept. And then nobody else has to solve this again. It just makes all coding agents more powerful. That's the dream. But for us, this is a completely necessary part to actually explore our coding agent further, because we want that coding agent to actually have it's I'm really looking forward to start sharing some. There's some stuff brewing, and I'm very excited about all the stuff I'm doing now, and I hope there are opportunities in the future to get some help to make these ideas become real. But yeah, I'll share more of that as soon as I have a chance. Oh, did I? Cool. So what we're going to do now, we're just going to try to generate a full set of documentation, and probably something will go wrong, and I'm going to spend some money on this, but that's fine. And what we're going to do when this is running, then we're going to say, okay, we have a good enough dependency rag now to actually start making some queries to our code base to start using Firebase and implementing things and analyze how well it uses that retrieval to extend the context of the or extend the prompt and see how it actually does things now. Yeah, this is going to be interesting. So let's try generating all that documentation, because that's going to be so nice to just kind of finish this chapter and then jump into the next chapter. Yeah, exactly. It's going to actually generate good code. Like, I wish I would show you a demo of this thing, because I started with, like, when I first started learning about AI and LLMs and all of this stuff, I tried to build like an agent before really at least learning about agents and agentic workflows and stuff. So I had like this single LLM that had a bunch of functions and could do a lot of different things. But then as I learned more, doc ID. Oh, yes, sorry. That's annoying. I should set true here. Because I removed the dependency, right? But then I didn't... I already had a document based on that dependency. So I should allow it to override it. But it was pretty fast, right? That was kind of crazy. I wonder how. Yeah, let's see what it actually generates. But yeah, that's interesting. What was I talking about? Yeah, the coding agent. And then I built this new agent based on all the. Oh, dependency types not found. Ah, I wish. Oh, we should also. Dependency types not found. Okay, we broke something. Let me just finish what I said. But then I learned about RAG. Well, I learned about embeddings, but not like how fundamental RAG is to understanding the context of the current context of like the world, or what you're actually, in this case, contributing code to. I kind of thought about this agent being the thing that, yeah, I don't know how to explain it. Like my perspective shifted on how important RAG is, to kind of sum it up shortly, in short. But then I also played around with this very simple prompt to sandbox thing, which made it perfectly clear that no, you need to have dependency RAG. If you don't have that, you cannot generate sandboxes. So I learned something there, and then and this other thing I also learned playing around with this is that I'm actually not, so yeah, I have a code RAG here, but the code RAG isn't the actual code. Each file is a human language summary. It's a LLM summary of what the file does. And the reason I do that is because this agent is here to contribute with things. It isn't here to tell you about functions and variables and stuff. It needs to understand conceptually what the different files does, so that when you prompt, it does a RAG on human language of what files do, as opposed to trying to map a human language prompt into functions and variables. I have no idea how much more efficient that is. But the point is that I'm not interested, as I said, in snippets of functions and variables. I'm interested in what files are relevant for this prompt. That's what I'm interested in. So having a summary of what those files do, intuitively in my split between my brain and stomach, it makes more sense to find relevant files if you have a human language summary of what that file does and what's its concept. But if I had a prompt that was like, where is the function that does this, then that wouldn't work, right? But we're not creating like a co-pilot low-level engineering thing here. We're creating an agent that conceptually, you can give a conceptual prompt and it should be able to actually make a conceptual change to your code base, if that makes sense. But we'll see, like, if that does actually make sense. Where did it go wrong here? Oh, interesting. How does React project node modules? Okay. Oh, did I actually change the... I didn't do that, did I? So we're gonna delete that one. We forgot to do... Oh, come on. I'm gonna do that. But what about React DOM here? And I saw another problem as well. Oh, we have to do definitely type. Oh, sorry. Okay, so we have a couple of bugs here. First of all, we're not gonna... So missing dependencies would be... Why did it go through React DOM? Didn't I add... I find that weird. Why did it go through React DOM? Oh, it's because I'm... Wait, package JSON. Yeah, that's weird. Oh, it's empty. That's why. That's weird. Anyways, so that was weird. Oh, and then... Oh, shit. I think it's because we're throwing an error somewhere here. Where are we actually throwing that error? Okay. Anyways, the problem was here. We are going through... Where are you? Learn missing dot export. We shouldn't throw an error here. It just means that it should continue. Okay, so we need to move this. I'm just gonna do a simple if keys with types. We're gonna do this. So we're basically first checking if we have an exports field with types, that's what we're gonna go for. And then this will be, or we're gonna check with definitely typed. Resolving types from definitely typed. Okay. Oh, interesting. Did it go again? Oh, look at this. Dependency typings not found. Okay, dependency typings not found. I need to know what it's from. Resolving types from exports. So this is vertex IA AI. But why are these happening? Resolving nested type. Why are these resolving types from exports? Yeah. Yeah, maybe I should not throw. Maybe I should just return empty. Yeah, I was thinking there was something wrong in the... I just wonder why it didn't find any. But is it the vertex AI thing that's causing it? I just wonder what it looks like. Firebase vertex AI preview. That seems fine. Oh, how do I give it some more info about where we are at? Resolving types from exports. Okay, so here it goes through all the exports at the top level. It finds all the type thingies. But then some package has its own exports. Or I guess each of them has that. Oh, where do we go? Yeah, sorry. So, yeah. So, Vertex AI Preview has its own set of exports with types pointing to whatever. Which is fine. I just don't understand which one that failed. Should I pass? So what happened here? It was here resolving types from exports for one of these nested things, and then some of them it couldn't find any typing. So it might just be. So maybe it's fine. Like, okay, so let's remove the error, and we're rather gonna console.log dependency has no types. And then we're just going to look at the dependency. Yeah. Warning. Yeah. Dependency has no types. And then this dependency would actually be the like joined at Firebase or Firebase slash something. Yeah, I'm just reflecting on that. You might have... No, let's just do this for now. Oh my God. OMG. Yeah, and then I guess we'll just return an empty array. Cool. Oh my God. Oh my God. Okay, let's try again. Oh, what happened here? No search file or project. Oh, interesting. Source Cordova web extension Firestore Lite. Okay, but I guess this is fine. And then resolving nested types from /index. Okay, interesting. Resolving nested types from... So it should... Oh, interesting. It's a ... I think I should just check dot. Because now we try to resolve like this as a package, which is wrong. Yeah. This is interesting though. Source? Does it actually have source? Interesting. I think it's fine with, or we can like check both. Like if it's, or let's just do this. All right, let's go again. At least it breaks on the resolving the type, so it's not actually, we're not wasting money here yet. Internal index. Oh, fuck. Fuck. These exports, they don't have file extension. They don't have file extension. So the question is, do we just add that? What was this? Auth dist. What was it? Internal. Wow. Oh, look at this. Export. Oh, look at this. It's just a bunch of exports. Well, we have logic for this now, so that's good. But does it actually have this? Look at that. Okay, fine. That should be fine. But the problem is the file extension. So since this is type definitions, I think we should be able to just add it. It would, like, a type definition would never reference itself by. I think it's safe to just say DTS. Yeah, I think they're all the same extension. Because, like, you would never, like, the type definition file itself would never reference another type definition file using the extension, I assume. And you cannot export anything else than another. Well, okay, that's not completely true. So we had, so this goes to, no, DTS. Yeah. Yeah. Let's just be brute about this first, and then we can add a check if needed. Wow, interesting. So, okay, let's just keep taking each problem at a time. So this would be, oh my god. Like, if you can make Firebase work, I feel like you can make anything work. So this is internal, wait. Auth dist internal. Oh, it didn't, sorry. This is more how it, this should be a dot dot into off. What? It doesn't have any source. Where's that coming from? Firebase or busting? Where the hell is? Oh, sorry, it has source. Sorry. So what didn't it find? It didn't find. Well, it didn't resolve the. I thought join would actually. Doesn't join. So if you have, oh, I have to test this. How can I easily do that? Can I do that like with node path.join? Yeah, I thought path.join would be like dist and then dot source. Yeah, why doesn't that work? So if you see here, it tries to resolve nested types /source, and we are in types path. Okay, let's types from types path. Let's just do this and run it again. So from in and then it should do in, oh, it is internal. Sorry. No, wait, internal. Why is it still in internal? I'm resolving it from... Wait, this is something else. No such file or directory. Why are you trying to read that? This is API authentication, IDP. Oh, here it is. Oh, okay, let's see. So that's source API authentication IDP DTS. But okay, so I have this path. Okay, let's see. I'm doing something wrong here. So path.join. And when I do /source foo.dts. Yeah, exactly. I thought this would work. Is it resolve I'm going to use instead of join? I always confuse it too. It's like slice and splice. Look at that. It should be resolve, not join. I actually think all of these should be... Yeah, some of them can be join. Okay, what about now? Right. Wait, it's the same thing? Internal source API authentication IDP.d. Oh, interesting. No module Firebase auth dist. Yeah, I think some of the joins are correct. It's like when you actually... What's the problem with resolve? There's a problem with resolve if you don't use it right. I think it takes your current directory or something. Yeah, so if it's not an absolute path, resolves to from leftmost from. Yeah, resolve to root directory. Yeah, that's what I meant. So if you actually just want to join paths, not to include like the root directory. But yeah, I guess I mostly want to do that in this case. Yeah, except for the where we do the key thingy. Like we take the exports key, sorry, the dependency name with the exports key. That's not a resolve because we don't, that's just generating a name based on path. But yeah, I guess most of these can be resolved. Yeah, that's interesting. Like, okay, mental note. Use resolve when you actually want to resolve path from the file system. And then it's and then join if you just want to generate paths unrelated to the file system. Yeah, that's a good one. So we can do resolve here as well. Here we can resolve. Cool. But what the hell? Isn't this an actual path? No such file or directory. Workspace project. Node modules. Firebase auth dist internal source API authentication idp.d.ts. Copy path. This is... Wait, what happened? Oh. What the hell? Wait, what is this? Oh, sorry. Oh, yeah, there's something additional here. Oh. Oh, fuck. Seriously? So, oh my god, this isn't good. So we have internal, and this does just dot dot, which goes into, wait, why does resolve? Wait, it's still wrong. Why doesn't this resolve to? Why does this resolve to internal source? Yeah, but just doing it in the terminal here, it's wrong. You know what? I noticed that, like, you need to split these things up. Like, if you actually split them up, I've noticed that they often work. No, it still doesn't work. I'm confused. I'm going. Why does internal stay? I'm going up. I'm going up. Why is it still in internal? What the fudge? Is it because... Oh, wait a minute. I need to drop the file. Yeah, that's it. That's it. When we... where was it? When we do this... from the types path, we need to drop the actual file name. You cannot resolve a path from a file name. We can only resolve a path from a path. So we need to remove the actual file name here. How do we do that? Node remove file name from path. I guess we can just split and then... Is it base name? Path. Oh, that's the opposite. I would just want to... Is it dir? Path dir. Node path get directory. Yeah, it's dir name. Okay, cool. So this should be path dot dir name types path. Now we should be good. Okay, we did get further though. So why isn't this valid? So this is off this source. Where are we? Oh, need to go further up. This source core persistent instance. Oh. So yeah, we definitely need to run a test. So it can of course import a directory and then it needs to resolve to index. We don't know that. We have to test it. Let's see. Oops. Okay, getting smarter by the day. Oh, by the... Sorry, I just need to read something. Cool. Okay, let's see. How are we going to do this? We can't really... So yeah, I think we should do a test here. We should do... what was it? Was it called? Stat? So... is directory... Isn't there like a fs? Is that stat? Isn't that stat? I think it's stat. Yeah. Stat tells you if it's... So we know that it exists at least. So we're gonna say stat is that that... Yeah, we have to call it. So if it's a directory, it's stat, not state. Then we're gonna do a path. So now we just want to add something to it, right? So we just want to add index DTS. Yeah, so if it's a directory, we're gonna just add index DTS to the path. And if it's not a directory, we're just gonna add DTS. Oh, okay, so now we have another one. No search file or directory. Okay, so now we got an actual error on stat. But where did that come from? No search file or directory. I wonder where... there's just so much happening here. I can't... Yeah, didn't we do that? Dir name? Dot dir name. Yeah, so like the types... Oh yeah, sorry. I wonder how... I think I can actually configure like how... let me check this. I did... where is that? Ecamm... stream... Like the latency of the stream. What was that a thing you did specifically for YouTube? I'm gonna check that because I did configure that once, the latency of the stream. And yeah, preferably it's like immediate. But we're doing things I wonder what this is. So it's doing stat on export path. I wonder what this is. So it's doing /index. I would love some more information here. But shouldn't that be... is it this one it's trying to resolve? Like we're doing so many things in parallel here. No, this, it has to be this one, of course. So this is this internal index, and then there's a reference here to /, yeah, export from /index, and that results in what did it try? Path. Oh, okay, let's see. Why did that fail? Why does it say stat? No search file or directory. But that's true, right? But oh, sorry. My mistake. I'm just thinking wrong about this. So we're doing we're statting this thing. But we don't know yet here. We don't have. So if this stat fails, it means that it is a file. Wait, what the hell am I testing here? Oh, sorry. We need to what the hell? So here we're basically testing if it's... I thought this would resolve regardless. Oh, because it doesn't have the extension, of course. So if it's a file, it doesn't have the extension, so it doesn't find it. Okay. So this can fail because it doesn't have the extension yet. So if it fails, it means... Okay. So let's just do this. Is directory. So if it's okay, because none of these export paths has like .dts in them. So if it goes fine, then it is a directory, or it would be false. I should comment the shit out of this. No exports are explicit to DTS. So if the stat fails, it means it's a directory. Yeah, I think this will work. Maybe. Wait, now we're back at the other one. No such file. What the hell? So is directory. I guess this is the... Wait. Why did this fail now? And let me try again. Why? I'm confused. So if it is a directory, we're gonna add index to it. And this is a directory. Oh wait, does it have both? No wait, that doesn't make any sense. Now I'm confused again. Where is it? So the persistence thing is here, source core. So we have core persistence, it is a directory. Oh, sorry. If the stat fails, it means it's a directory. Like, but all of them should fail, right? Because none of them points to a file. But we just need to know if it. Wait, now I'm confused. Like, if it's true, if the stat goes through, it has to be a directory because none of them actually points to the file name. No such file or directory. Yeah, that's true. Because it's a... why does it say that this isn't a... So it's checking this thing. It's checking this thing, and this thing is a directory. Ah, I'm confused. Wait, persistence. Yeah, so this is the thing that fails. Core, source core, persistence. It's a folder, for God's sake. Oh, wait a minute. Oh, sorry. It needs to resolve. God damn it. So first we need to. This is so confusing. So we have. It of course it needs to stat the whole thing. So we need to resolve. Path. God damn it! This is complicated. And then the export. So we need to stat the full path, like the resolved path. Oh, look at this. String too long. Now it's now we're getting somewhere. Oh. Look at that. There's too much here. Okay. So what does this mean? Okay, so we're resolving all the types now. That's great. But the result is too much information. So that means we do need to split it up. So then the question, now we have a different question to answer. Okay, but this is great. We got our dependency resolvement done. I'm just gonna quickly document. Resolves type definitions, including export from other files. We assume all exports reference directories with a index.dts file or an actual DTS file, which we resolve manually. We identify exports using a simple regexp for now. Like if they can use regexp to generate tokens for LLMs, we can use regexp to for exports. Like I would imagine like a tokenizer to be way more complicated than just a bunch of regexps, or just one big regexp, as I understand it. So what? Yes. So our problem now is that where we actually go and generate all this stuff. Let's see if we can. We bring in all the types, and this is too much information, which I can understand. So the question now is, how do we actually store this is not really a big deal. So basically what we need to do is we need to resolve, so we're missing dependencies, and within each yeah, so I think we should move things again. So let's go here, and we need to flatten this. So what we're gonna do is, what the hell? Yeah. So what we're gonna do here is to, like, another problem is, well, no, that's not a problem. Okay, so we have missing dependencies here, and what we want to do is we're gonna resolve missing dependencies, but we're gonna create a new list that holds, where's the readme? There's the readme. So this is async. So we have missing dependencies, but we need to create a bigger list with the nested dependencies. Well, not nested as in like proxied dependencies, I guess. So what we can do is we can reduce over missing dependencies. The problem is that this is async, so we can't really reduce over it. And then this shouldn't be missing dependencies. This should really be. Yeah, another question is, what do we do with the readme? I guess that's the thing we need to answer, is like, what do we do? Okay, so what we're gonna do here is that if a package has an exports field, we are just gonna make the readme its own documentation. Oh, that doesn't make sense. Think, because you might have an exports field pointing to some internal typing. So this is more, what is the problem here? Is it just a general size problem that we need to split things up? Or is it that we generally want to make exports? No, we're gonna, yeah, what we can do is like one of these types is like the first one is always the name is the missing dependency itself. So what we can do is we can include the README there. And then with any types it has resolved. Yeah, that's another thing we need to handle is okay, we're gonna do that. So basically the first type, no, if the dependency you know what, we're just gonna generate the prompts. Yes, that's what we're gonna do. Or messages. So let's do that. Const messages, but it also needs to know. Okay, so it needs a dependency. Yeah. Dependency will now be the name dependency, which might be like a export type of thing, export key. So it needs that, and then it has the README. So if the dependency equals the missing, like the, okay, let's call it parent dependency, or whatever, and then or root dependency or something. So if the root dependency is the same as the dependency, then we're going to add the README as well. So we're going to include that. Or should we just do that in the... Oh, God damn it. So this needs to hold the dependency. No, we don't need a root dependency. We're just going to generate messages. Okay, so const messages would be an array of dependency string and message string. And what we're going to do is we're going to iterate over our missing dependencies. So we're going to await. I guess we can just map this. So we're going to await promise.all missing dependencies map. Where did it go? Oh. And this is going to be async dependency finding, and then we're going to find all this stuff. And now we have our types and we have our README. So what we're going to do now is that we're going to return our types, but we want to we're going to flatten it. How the hell do we flatten this? Maybe we could just flatten it at the end. Or would it make sense to like, it doesn't make sense to flat map this one because it's a promise. We have to wait until we get the full result. So I think we need to do this. And then we're gonna do flat messages. flat, and then we're going to map over them, and then this is going to be the message dependency. This is how we're going to do it. And then we're going to take this, and that's going to be the message. Oh, come on. This is going to be the message. What we're going to do now is we're just going to return types, and we're going to map over those types. And we are going to, let's just write it out first. So types will be the name and the actual types. And now we're just going to check if name equals dependency. It means it's the root thing. And then we're going to return, what was it? Dependency. And then message would be the full thing. We don't need the mapping anymore. Let's see. Okay. So could you generate some usage examples from this README and TypeScript definitions of a library called dependency? Of a dependency called dependency. And then if this is not the case, we are going to return dependency is the actual name. What happened there? Dependency would be in the name of the thing, which would then be like Firebase/auth, Firebase blah, blah, blah. And then we should say the message is, it's kind of the same. But now we don't have a README anymore. Could you generate some from this type, from these TypeScript definitions of a dependency called dependency? Like that. So now we have this array of messages that we flatten, and now we're basically just generating more dependencies. So we do still have a dependency called Firebase, and that dependency will include any type definitions for that specific package, but also the README. But then the other ones, they don't have a README. They just have type dependencies. So now in theory, we should be generating oh, look at that. It's already started. Oh, this is interesting. Oh, did I? We're spending money now. Muncies. Yeah. Oh, fuck. Look at this. Why does it do this? Is this from the actual... Like, it's not wrong. It's just that... Yeah, let's look at app check while we're waiting. So Firebase app check. Where is the types app check? Why does it say Firebase app check? So this is what I'm worried about, is that it's making these assumptions. There's no reference in the types here. I'm not saying even that it should learn Firebase app check. I'm saying that it should learn Firebase / app - check. But it's generating these kinds of things. It is not like strictly wrong. You can still do this using usage examples created for. But I was wondering if there was any like. No. So this is coming from its training data, and this is a problem. Because all of these imports should be from Firebase / app check. Like, again, it's not wrong. It will still work. But it just doesn't have any reference to it. Oh, wow. That was an expensive one. Learning Firestore. You see here it uses Firebase Firestore. It's interesting. But I think that's something that could be handled with prompt. But suddenly here it has Firebase database. Yeah, but I think that can be handled with prompt engineering. Like we know what we're generating. We're creating usage examples for TypeScript libraries. So we can say that it should only use like the import of this one. Because this is kind of hallucination, but yeah. It's very interesting though. Like we are literally learning how to use this thing. But yeah, I want to do another, like, we're just gonna have something to work on here. And then we can do like a separate project where we optimize the prompt for creating these usage examples. I think there's a lot that can be done there. But that's not the most difficult part. The most difficult part is what we've been doing here. But it's interesting. Like, I have no idea how much of this. What was I gonna say? I wonder how much of this is coming from the training data. Like, there's no way to know that, but it does. Like, that is like the biggest problem. Is I wish there was a way. Like, I think LLMs, they shouldn't learn dependencies. They shouldn't train on documentation like any dependencies. It should train on language. It should solve problems using a language. And then if it knows JavaScript and TypeScript, then it should be able to learn any dependency. And then there's no hallucination, right? Just because it had like 1,000 documents on like an old version of Firebase, it starts hallucinating a bunch of stuff from that doesn't match the current version of Firebase. Even though during its learning of the dependency, it will still hallucinate. Yeah, I want to make that statement. I think it's a mistake to train LLMs on dependencies. They should only train on language. When it comes to code. But it's the same thing that happens in normal language, right? So what if you are like you're a lawyer, and what you really need LLM to do is to produce language, not to make like it shouldn't be trained on any laws or anything, because laws change. So if it has like thousands of documents referencing a law that has changed, even though you create a RAG for retrieving the current state of laws, it can hallucinate on this old knowledge. I find that very interesting. So it's almost like look at us learning. This is awesome. So it's almost like to be able to get like an LLM to learn to kind of reason and all of like these general things, it comes with the cost of hallucination, and we need to band-aid that when we create solutions for it or solutions with it. Wait, real-time database? Oh, this is the compat thing. Oh, this is interesting. What is compat? What are these compat packages? App check, app compat. Does it say anything? Which recreates the V8 API. Thanks for that. Yeah. Like, why wouldn't it use the compat? I wonder how much money this was. Probably like a few dollars. Not that much. Like, yeah, it wasn't much. It's really cool though. It actually worked. I didn't think it would work. We should probably move this to repo. We get some proper external. It would be horrible if this. But again, it's like it's probably like what we're doing now is that we're kind of like you have two edges of using a dependency. You have strictly the typing, and then you have usage examples. And since we have a lack of reliable sources for usage examples, we're kind of generating usage from the typing, but the typing only holds. Yeah, it's very interesting. Like the usage examples it comes up with is hallucinations from its training data. I would think. Like if it hadn't learned Firebase in its training data, generating usage examples from current TypeScript type definitions, it will probably do at least a way worse job at that. Oh, look at that. We're done. Okay, let's just see that we actually have everything in here now. Dependencies, Firebase. Nice. That's a celebration. Good job. So what do we actually want to do now? Okay, so the project we have is like insanely simple. It's just like the default app with a counter. And I think we're just gonna try. Oh, I'm scared now. I'm so scared. We're gonna try to make some queries related to, like, yeah, initializing Firebase. The problem with Firebase is that you need to go to like a dashboard and stuff. So learning this documentation is not really to set up Firebase, it's to contribute to a Firebase project. That's why we have this. But what we could do, we can try to ask it how it would set up Firebase for this project. And or even just stating I want a database for this. And then see what it suggests that we do. Or like I want to persist my count in a database. Just that, and like see what it does. Okay, cool. I do want to move this to repo though. I'm actually not export to GitHub. So does it include? We have the doc store and everything. I'm a little bit scared. I'm gonna fork this because I'm afraid that something will go wrong. Yeah, it doesn't matter. Let's fork this and try to create a repo out of it. Are we still having infra issues? Oh. This is also weird. Like it shouldn't work like this. We forked it. It should be just be like a 2-second thing. No new dependencies. Do we have everything in here? Great. Okay, let's export this to GitHub. Let's call it LLamaIndex code agent on my thing. I can make it public. That's fine. Okay. I'm looking forward to the I watched the Xbox showcase yesterday. Oh my god, that was some amazing stuff. Like they really kick ass. Like they're way better at doing these showcases than PlayStation or Sony. Really, really good. Anyways, and today it's WWDC with Apple, which I'm looking forward to. Gonna be awesome to see some announcements on their collaboration with OpenAI. I have a feeling that they are gonna, to some degree, run maybe a specialized model locally in the device or something. Oh yeah, what's this? Can I try it again? Like that's the thing. Like what's unique about Apple is that they can make the interactions with the LLM insanely fast, which is gonna be this is gonna be the next big wow moment. It started with ChatGPT. Oh my god. I think we're fine now. What's happening here? Was ChatGPT. The next wow moment is going to be to have like a natural conversation using your iPhone with this thing. Yeah, whatever. I don't care about you. Let's delete you. Okay. So we're gonna try to have a conversation with this thing. I think I can go, or not a conversation, but we're gonna try to ask it to add persistence to the count and see what it suggests doing. Like it's not actually writing code now. I don't care about that. That's the easy part. Problematic part is what code does it intend to write? Okay, let's start it. Oh. So TSC Watch, doesn't it like actually build it first? On success. Do I have to build it first? Come on. What the hell is happening here? Cannot find module? Why isn't there a dist folder here? Hello. I don't understand. It built it. Yarn build, done. What's happening? God damn it. Where's the dist folder? It's not doing anything. What the hell? Root directory source. What the fuck is happening? Why isn't it building? Oh, what the hell? What the fuck is happening? What the fuck? No emit. Yeah, not using this option. Yeah. What's happening? Why isn't it producing any output? I'm so confused by this. Why aren't you building? Build, God damn it. Oh my god, I'm so sick and tired of this. Build info? Is it? I don't know what that is. Wow. That was weird. Okay, now it works. Oh yeah, we need OpenAI key. Okay, I'm gonna just quickly change to double me, OpenAI API. Let's generate another API key. Llama agent repo, create secret key, copy that secret key, and we're going to shove that into settings and variables. OpenAI API key, and that restart micro VM. Let's see now. Oh my god, my butt. I should have taken a break. Ooh. Yeah, so what are we actually going to do now? So through all the conceptual thinking and all of that, there are other types of RAG. There's a RAG for the history of the project, like PRs and commits. Exactly what that contributes with, I'm not sure. I don't know to what extent my memory of PRs is contributing to my ability to contribute code to our code base. Maybe that's not too important, but one thing I know is really important is understanding the output of the code. So for a web application, that would be actually have images of the different states of the application. I think that's critical. And maybe that's something we should try to explore. How would we actually do that? That will be very interesting because that's going to be an important tool. So maybe our goal here isn't really to create an agent, is to figure out what kind of tools an agent would need. So now we kind of have this dependency rag thing, which is something anyone could benefit from. Yeah. But anyways, and then maybe we can figure out how to create a tool that actually is able to open a dev server, and either with the help of the user, like there's so many ways to approach it. So maybe the goal is to take these images to be able to, like the point is you really want this state machine that shows the different states the app can be in. And then actually that in and of itself is incredibly valuable. Because now the LLM doesn't only have code, it has this other format of what it's trying to do. Because when you ask it to change code, you're not really asking it to like, that's how I think about it. You can use an LLM to like write this function that does this thing, this transforms this data or whatever. But that's not what I think about when I think about an agent. An agent is go in and create a banner on our a banner that should appear when the user is over a certain limit or whatever. That kind of thing. And that means that it needs to have an understanding of not just the code, but the output of the code, like what the code represents, I think. And one part of that is a state machine. Another part of that is what it actually looks like. So you can think of a state machine showing all these states, and each state is an actual visual representation as well. So maybe that could be an idea that, no, let's not care that much about the image. Let's figure out how an engineer can generate a state chart, can manually write a state chart that the LLM can use to navigate the app. That will be really interesting. And then maybe the LLM can also update that state chart. So you wouldn't ask an LLM to, oh, here's an API for you to navigate any web application. Go and figure out how to validate this. It would rather be an agent that can take a change to a code and then update a state chart. Yeah, I find that very interesting. And that's also what I'm seeing here now. Like we're creating this agent now, but this agent is for writing code. I would create another agent to take a code change and produce or update the state chart. And then I would use another agent to take a state chart and map that to an API to navigate a web application. Something like that. Anyways, let's, how would you implement? So the prompt here says that it can only use the dependencies of the project. Persistence for the count. So what it's doing here is that it's going in and getting the project file structure, and then it reads the file content of the app. And then, oh. Oh, interesting. Yeah, it's not wrong. That is interesting. It's definitely not wrong. I should be more explicit. Okay, let's try again. How would you implement persistence in the cloud? Or let's see, how would you implement database persistence for the account? So you can think of project file structure as a type of RAG. Currently, it's a very primitive RAG. It just dumps the whole file structure, but this is important information. Like if you think about how you approach implementing something new, you have very much a notion of the file structure of the project. And reads the file content. Why isn't it reading the dependencies? Oh, wait, did I? Oh, sorry. Sorry. I hard coded this. Get project dependencies. Like we need to add we need to read the dependencies. Excuse me. So the question is, I think that's part of dependency RAG. We should have a function tool for that, or so this would be dependency RAG get dependencies. Does it need workspace path? I guess it does. So dependency RAG, sorry about that. Let's just, we're just gonna read it. Do we have a constructor? Okay. So this will be get dependencies. And it should be like name and description. Array of name, string, and description, string. Now the question is, we have, yeah, we're gonna check something. I do think, let's see, Firebase. I do think all of these. Yeah, do they have like, yeah, I wonder if, because we do not only have dependencies now is something else. So I think actually we need to do get dependencies. You know what? We're gonna dependencies. We're just gonna say public dependencies, and this is gonna be the array of name, string, and description string. Oops. because as we just worked on, there are certain dependencies that are like oh fuck, damn it. So dependencies for us isn't just the name of the package, it's the actual exports. So I think we need to do a little bit of refactor here. Yeah. Dist auth. Wait, auth dist auth. Yeah. I don't want to do this now. I need a break. Okay, so what we need to do is we have to refactor a little bit, because what we want to happen here is yeah, and this can't be dependencies. What we want to happen is that when we get dependencies, we're going to do the same lookup. We're going to go through everything. We're going to find all the packages, their exports, their type definition. So basically what it's going to return is not just Firebase as a dependency. It's actually going to go in and look at all the different, like Firebase auth, Firebase this, Firebase that. And then create a description for them using the package JSON. Yeah. So it's, yeah, we just have to generalize some of the functionality. Because now we're kind of mixing getting the paths and reading the file contents, and we don't need that. So we need to refactor so that we, in one place, we go and find all the typing paths, and or in one function we do that, and then we can use that function for this dependency retriever thing, and then we can use it for the actual building of usage examples as well. We don't have to run the usage examples again. We just need to change the logic so that we just get the paths and then we read all the actual type files. Though that's tricky. How would we do that? Because we do need to read them to actually be able to. Okay, I'm gonna think on that. But I'm really happy where we got with this. Like, we're one step closer to conceptually having a dependency rag, which I think is great. And then we now just need to fix what I just talked about, so we can actually start querying our agent again. Now we're going to play a little bit around with that, and then we're going to explore having a state chart. So instead of like, it seems more precise to have a state chart of the states of the application, that maybe the LLM can actually produce that based on its implementation. I'm not sure how you would do that, because if it's going to contribute to a code base, you wouldn't want engineers to create these state charts, right? Yeah. No, yeah, but having a tool like that would be amazing. So something to reflect and think about. And anyways, bye for now. We'll talk later.